All right, on the next page here, this is just a quick for your information, but the question, of course, always comes up like, why is that? Why is the slant asymptote equal to the quotient? So here's what happens. If I do a long division or a synthetic division on this problem, I would end up with this. I would end up with x plus 5 plus 4 over x minus 1. Now, we're taking or look at what happens as x goes out to infinity because we're trying to find, again, this line that it approaches as we go out to infinity or negative infinity. Now, remember what we said back in test one, we said we always want to plug in first. So if I plug in infinity here for all of my x's, I will get infinity plus 5 plus 4 over infinity minus 1. Now, if you look at this remainder, so remember that this x plus 5, that's my quotient, and then the 4 over the fraction, that represents the remainder. If you look at that remainder, plugging in infinity, you have 4 over a big number. You have that infinity minus 1, which will just go to infinity. And we learned in test 1 that anytime you have a big number in the denominator, that simply goes to 0. So what's going to happen to that remainder as x goes out to infinity is it will just go to 0. And so because that is dropping off as you go out to 0, what's going to matter and what's going to define that limit is not the remainder, but the quotient. And for that reason, the slant asymptote will be the quotient.